this problem says determine whether the given series is convergent or divergent, and then it gives us the infinite series. A rule of thumb is that if you see a series that has a factorial or even a number to a variable, then you want to try the ratio test first. When you're studying, it's always a good idea to be able to write out the definitions for what these tests are. So the ratio test says that if you have the series in the form of an infinite sum of the sequence an, then if you take the limit as n goes to infinity of the absolute value of an plus 1 over an, that will equal L. If L is less than 1, then the series converges. If L is greater than 1, then it diverges. And if L equals 1, the test is inconclusive. Okay, so that's pretty straightforward. This is actually one of the more intricate problems for the ratio test that I could find. It has a few tricks, but it's still kind of simple. Okay, so let's start by calling n to the 2n over 2 to the n times 2n factorial an. Then the absolute value of an plus 1 over an is the absolute value of n plus 1 to the 2n plus 1, and you just want to make sure you get the parentheses in correctly so you can distribute later. Then that's going to be to the 2n plus 1 times 2n plus 1 factorial. Then you're going to divide by a fraction, so you might as well multiply it by the reciprocal over n to the 2n. That's going to be an absolute value. This series is in the natural numbers always, so really when you look at it, this will always be greater than 0, so will this term and this term. So really the absolute value signs can go away, and let's just simplify for the next step that we write down. I will distribute and take away the absolute value signs. So that's going to be 2n plus 2 times 2 to the n times 2n factorial over 2n plus 1 times 2n plus 2 factorial over n to the 2n. So now let's cancel anything. If we take this term and this term, that's going to give us a 2 in the denominator. If we cancel this term and this term, that's going to give us 2n plus 1 and 2n plus 2 in the denominator. Then I'll simplify this as n plus 1 squared times n plus 1 to the 2n. And then this will have n to the 2n in the bottom. I'm going to pull out both the terms that are going to 2n, so that's going to be n plus 1 over n to the 2n. Then it will still be n plus 1 times n plus 1 over 2n plus 1. Then I'm going to pull out another 2 from here, so that will be times n plus 1. Then we can cancel an n plus 1 from the top and the bottom, so we can rewrite this again as 1 plus 1 over n to the 2n times n plus 1 over 4 times 2n plus 1. Okay, so I've simplified it. Now I want to consider what the limit will be when it goes to infinity of all this. One thing you can do is actually switch the 2 times n and separate it a little bit. So you have 1 plus 1 over n to the n, and you can think of this as squared. N plus 1 over 4 times 2 times 2n plus 1, and you can take 1 over n of the numerator and denominator. So the reason we did that is because this value is actually e, so it will be e squared times 1 plus 1 over n times 4 times 2 plus 1 over n, and that's all going to infinity, and we can just take the limit, so that will be e squared times 1 plus 1 over n goes to 0, so that's plus 0 over 8 plus 4 times 0, so that is e squared times 1 over 8. Because e squared is approximately 7.3, that means that e squared over 8 is less than 1. Thus, by the ratio test, we can conclude that the series converges. And we're done.